Hello, everybody, and welcome to the first Pain Geeks Unpublished of 2023. And we are super delighted to be joined by Dr. Elena Rocca, who was part of the Cause Health team that brought us the book. I always forget the title, it's quite a long one. Rethinking Causality, Complexity, and Evidence for the Unique Patient. And we've been sort of dipping in and out of this over the last couple of years. And last year we held the theme pain and causation, and we reread chapter 5. So it's absolutely wonderful to have you join us. Would you kindly introduce yourself to everybody
Yes.
and tell us where you are?
I will. Thank you, Laura. Very lovely to be here, and very nice that you're interested in the book and in this chapter, of course. My name is Elena Rocca, and I am Norway-based, although I'm originally Italian. I've been living here now for quite a lot of years. I work at the pharmacy department at Oslo Metropolitan University. I'm a pharmacist originally. And I have been involved in the Cause Health project since its very beginning. The project has been started by Dr. Rani Anium. Mm-hmm. I've been knowing her for quite some time before the project, actually, like more personally. We met in the North Pole, in Tromsø, the most northern university in the world, when she was doing her PhD there, yes. Yeah, so she has got the financing for this project, and she is a philosopher. And she wanted to get some non-philosophers, but philosopher-interested practitioners involved. Mm-hmm. And I was very happy to take a break from my practice to dig into this. And for me, it was also a novelty because I have a PhD in biomedicine. Mm-hmm. So it's not that I am professionally a philosopher at all. But I've been very philosophy interested for one or the other reason, I don't know. In Italy, we have quite a big space for philosophy since high school. So I don't know where it comes from, actually. But I think that these things are very, very exciting and relevant. So that was 2015. Then we started this very exciting project where we had the luck to involve a lot of practitioners and clinicians. And toward the end of the project lasted originally 3 years, then there was a kickoff 3 more years. We have written this book where Rani had a brilliant idea. Originally, it just had to be a book about our research results. But then Rani had a brilliant idea to, instead of just writing our theoretical part, to involve all the clinicians that were very, very keen on cause health, to write in the second part how the theory applies to the clinical practice, because otherwise it is a little bit, it's very hard to see how it can, some philosophy can actually change the practice as we're claiming.
Yeah, yeah, and I think that's what makes it just so accessible, and especially as clinicians. And I think what we find, well, certainly what I have found on my personal journey with being, sort of like in the Cause Health outer circle, and sort of watching the project develop and going to the conference in Nottingham that year, and like it has even just the idea that we can think about philosophy of science, we can think about causation, has opened up such a huge contemplative space for me as a clinician. And then that's what I hear from other clinicians. It's like, oh God, I hadn't even thought of it like this before. And then boom, there's this whole other world opened up, and it's quite exciting. Yeah,
I agree. Yes. I'm now trying to introduce it to pharmacy study. This is a little bit of a harder one because pharmacy is. We were going to talk about now. Introduce a term that probably we're going to talk about later, but it's a reductionist approach by definition, because we're trying to fix something at molecular level, fix
Yeah.
a higher complexity problem starting from the molecular level. But nevertheless, I am trying to introduce it, but it's hard to change the culture, you know,
Yeah.
because that everyone has been educated a certain way.
Yeah.
So myself,
Yeah.
so for me, it was quite a journey. And of course, when you come to a completely new environment where no one ever heard of that, then it's not simple.
No, no, it's not. And I really, really like, I'm so glad that you're here doing it. So thank you for putting the time and investing the energy and the emotional work into doing all of this. Um, what what was that like then? So just to go back a little bit and think about your journey, you know, I mean, we always think of, like, I'm a physiotherapist by background. We always think of physio as being quite biomedically focused, but not really. When I think about what the training is for a pharmacist, like that's really reducing down to this molecular level, you know, and what we do is we sort of reduce complex phenomena down to very simple biomechanics. That's what we tend to do. That's where our reductionism tends to sit. Um, but what was that journey like for you then? Did you sort of were you introduced to this by Rani, or were you already here and you were like, yes, this is what we need to be looking at?
Oh, thank you for that question. That is quite, I think, a strange story. It started, well, I was a bit interested from before, introduced into philosophy from early age. Maybe it's the Italian tradition. So,
Yeah.
but really, I think that what started it is when I was in a field work in Brazil. After my PhD, which was in biomedicine, I was concentrating in genetics.
Okay.
And then I took a research project in Brazil where from biomedicine, I was looking at genetically modified proteins in crops. There in
Right.
South Brazil, there's a lot extended production of genetically modified maize and soya. And I
Mhm.
was trying to look at how these genetically modified proteins might impact the immune system of mammals who are exposed. And
Okay, yeah.
I was looking at this in I was actually trying to catch mice and small mammals in the field in that lived in wood
Yeah.
close to the field. Um,
Right.
and you know, it was a very big experience from many points of view. First
Yeah.
of all, because I was, you know, involved for the first time. I was out of the lab and involved with the reality of farmers
Hmm.
and seeing how there's all a social
Yeah.
dimension to it. And
Yeah.
it was very, I would say, healthy for me to come out from
Hmm.
the lab and get that dimension. But the
Yeah.
important thing for me
That
was that,
wider socio-political dimension.
yeah, to
Yeah.
see how the impact, I mean, that I was focusing on the, of course, molecular biology, see how the impact of some molecular
Hmm.
technique, biomedical technique, technology can impact the society. I mean, for me, and I have no political science background either. So it was really very interesting. But the interesting thing was when I was reading literature for this, you know, toxicology, to look at its impact. So what do we know about the impact? And the funny thing was that I noticed that there was common evidence. You know, the evidence was there, the experiments were there, but experts disagreed on not on the facts on the experiments, but on the meaning and the evaluation of what this evidence
Yeah.
meant.
Hmm.
So they had different risk evaluations
Hmm.
from common evidence. And that was really strange for me. That was the first time I was faced with this.
Yeah.
And then I had philosophy of science friends. Of course, everything helps. That there were many discussions on that. So there must be something that goes beyond the facts.
Hmm.
You know, here there's
Yeah.
not disagreement on facts. There must be disagreement on something else because the facts are common. What is this? And it wasn't explicitly said. And then, you know, through this philosophical analysis, one can make analysis of arguments.
Hmm.
You know, logicians have way to analyze arguments, and then you see that there are some premises that are unstated, but they're there. For instance, if you think deterministic or undeterministic, you have that premise, and these are implicit assumptions. So I started to get interested on the way these implicit assumptions change the way we look at evidence. And then I started to see this everywhere. You know, that suddenly I saw this everywhere. You know, it was really interesting.
I love that you say that. Like, suddenly I could see this everywhere, because I think that is such a shared experience with clinicians when we start saying, oh, actually, you know, that there is this kind of assumption that, you know, this I don't know, let's say this monocausal property causes this big phenomena, but do we know that that assumption is right? And then all of a sudden it's like, oh wait, we're not questioning any of this underpinning stuff. You know, sometimes we just go along with it. It's like randomized control trials. You know, we just go along with this idea that that is the best evidence. But is it? You know.
Yeah, we are at the moment writing a manuscript together with Rani and another causal philosopher, Fredrik Andersen, and we decided to call that institutionalized philosophical basic assumptions or philosophical bias, because they are, you know, they are institutionalized. So this pyramid of evidence, where randomized controlled trials, so controlled experiments are the best to see causality. Has implicit assumptions that causality is a difference maker, because controlled experiments are the best way to see difference. You know? But because they're institutionalized, you don't have to reflect exactly as you say, no?
Well, actually, there is a culture of not reflecting. So, I mean, I know from my own recent experience of being back in, I had to do a re-registration course for physiotherapy here, and, you know, asking, well, you know, is this the right methodology for this type of question and for this type of experience? And because we're taught to this level and not necessarily taught to think around it, the teachers also feel very uncomfortable when you question their knowledge. And so, this is where institutional culture as well can also play a part. You know, it's not just this is how it is. It's this is how it is, and don't ask difficult questions. You know.
Yes, I agree. It is an institutional culture. So, you know, when people have been instructed or have learned a certain thing, then it's difficult to. And I mean, and also there is an uncomfort because there's so much good in having introduced and having randomized controlled trials and having improved the methodology for certain things. Of course, I mean, before that we were much worse off when we couldn't, you know, for many things, for certain things, for certain level of knowledge. For instance, to look at the difference making at the statistical level. This is an important thing because it's a symptom. It shows something about causality. But then when you start saying, well, it's not everything there is to causality in the single person, then people start to be very uncomfortable, because it sounds like we say that you shouldn't look at randomized controlled trials. You shouldn't make your research when you are in front of a patient. So, which is not what we're saying.
No, no, it's very much an and situation, right? It's like we need this information and we need to be able to contextualize it, understand the limitations, and remember that the person we're working with was not in that trial. You know, the person we're working with is an individual that may respond completely differently or exactly the same to the way that the evidence that we have over here. We have to listen to the person in front of us and use our clinical reasoning, our clinical judgment, and our creative, I suppose, the creative license that we get given to hold these therapeutic relationships. Absolutely. But that's
exactly. And I think that what is most difficult, so when you look at evidence-based practice, so you've got, you know, the three circles of, you know, the evidence, the context, and then the patient, application to the context of the patient. So I think that we've got a lot about a lot of tools about evaluating the evidence. We've got, a lot of database. We've got people evaluating the evidence for us, so we can go to up-to-date, check the evidence. But I think that when the clinician then is left to look at how this applies to the context, I think that we have, it's a knowledge, of course, you have to put it in context, but what is a little bit, I think, understudied, or there are not so many tools for the clinician to say, okay, how do I do this though? How do I know whether this applies to my context? And this is a mega problem.
Yeah.
The problem of it worked there, it will work here, was defined by a very influential philosopher of science, Nancy Cartwright. She said this is a mega problem because, it's really difficult because you need to know what she calls the machinery, so the mechanism in place, the local mechanism in place, and not only that, but which local mechanisms are of relevance. I mean, that after you have the answer, it's easy to see that, but before it's not easy. So I think that we need more conceptual research of that type, not to leave the clinicians alone with the evidence, and then look, and then you have to apply it. Yeah, but I think that there's a need of a little bit more guidance for that.
Yeah, and I mean, I suppose that's the difficulty because, in most therapeutic encounters, the human body is a closed system. We don't see on the inside, and we are massively complex, right? So we have lots of different ways of producing similar outcomes. Lots of different I suppose, like different processes, and this is the limitation of my biological knowledge, where you can pick up probably, but one person might have this experience, but the actual biological coding of that experience could be very different to another person who would also report having the same experience, but they might be getting there in different ways. And this is the thing that we don't see all the time in practice. So we're working with a closed, very highly complex system, and a very complex environment, and a very complex political sphere, and all of this is adding to the complexity. And then I suppose the question is, well, what is the best guide within all of that? Is at which level are we working? And that's where I think it can be really useful to think, well, the best thing we can do is ask the patient and highly value their self-report of their experience, without necessarily always needing to have that agreed in some place over there.
Yes, this is what we are trying to say in this chapter, where we talk about complexity. And I guess that it's because what you say, I mean, it was the most, when I look at the download counts of the book, that was far the most, at least downloaded, so maybe also read chapter by clinicians. And I think it's because clinicians, of course, they have to face this complexity issue and this context. And I mean, clinicians have to say, like, they have knowledge from somewhere, and they have to use the knowledge from somewhere else to solve another problem. I mean, this is the dilemma of clinicians. So they will always try to solve something, picking from something else, because either it is the evidence or previous experience, or so. And of course, they have to deal with this problem of complexity. So maybe this is why it's very popular and very read. I don't know whether it gives any help. We hope so. It's a bit theoretical.
Well, I think that that's necessary, actually, because I think that what we're learning, and certainly my experience anyway, and the way that I practice, is that I don't necessarily need a tool to do my job in the clinic. What I need is information to help me create the most relevant environment for this person, and that really helps. Having the theory really helps. And I was saying just before we came on, we have this we're taught at undergraduate level sort of like biomedicine and reductionism is wrong and biopsychosocial approach is right, but then we don't really ever get taught either of those things. So maybe it's a nice opportunity for us to just explore a little bit, like, what do we mean by the biomedical model of health? Like, what actually is that? What does that look like?
Well, it's the dominant, I would say, still the dominant way of thinking when you think about medicine. Mm-hmm. And it comes, and maybe for originally good reasons. Let's say that if we start from the very beginning, the biomedical model of health starts from with some very, very important basic discoveries, like the germ theory of illness, mm-hmm. With Koch and Pasteur, that transformed the way to the previous way we had to look at illness and health as a kind of curse, mysterious things that were not necessarily scientific, to something that has an explanation, tangible, mm-hmm. that we can do something on. So it offers tools, mm-hmm. And very important tools to interact and act on illness and make people healthy. And of course, these tools are tools that changed history of humanity, like, for example, antibiotics.
Yeah.
So with this revolution, I would say, we got a lot of course important tools, but also we got a culture, mm-hmm. As a byproduct. And this culture is this thinking that illness, mm-hmm. is due to some kind of damage, mm-hmm. at the lower level of complexity. Virchow, which is considered the father of pathophysiology, he said that all illness comes from a damaged cell. So the idea that there is always a physical explanation which comes from a lower level of complexity that can explain a higher level of illness.
And when we say lower level of complexity, you really, just for my own language, so I get it right in my head, you're meaning like when we simplify, it's this kind of, the lower level is down here as we reduce it into less variables or a less complex system, and higher level is at the gross level, the human level perhaps, or something like that.
Yeah, it means parts and whole. If you think parts and whole, like you've got the whole and you can divide it in parts. So mm-hmm. if you take one part, is a lower level. For instance, a human body can be divided in organs.
Yeah.
You take an organ, it's a lower level of complexity respect to the whole body. But then each organ can be divided in, for instance, cells. Yeah. Then it's the next level of complexity. But cells can be divided, that are made of molecules.
Yeah.
Then you go to the molecule, is the next one. And then so and so, like you arrive to, I guess, subatomic particles.
Yeah. It's like a spiral that you just keep going. Maybe it never ends.
Yeah, maybe it never ends. But the idea is that when you look, the lower level you can look at, mm-hmm. For instance, lower relevant level. For instance, mm-hmm. when you talk about illness, it's probably the lower level, relevant level is molecules. Yeah. I would say, or cells, molecules, I would say, rather than, subatomic particles. Although you can say that electrons, of course, moving of electrons determines firing of neurons. In the end, you could go down. So you go down to the physical. In the end, this idea that physics is the most fundamental area, because it gives the most fundamental explanation of everything that comes after. Like, without the electrons moving, in the end, you wouldn't. Yes. So this is a way of understanding illness that we inherited and then of course works for a number of things. Many times it works to use antibiotics if you have a bacterial infection.
Yeah.
Because one of the determining factor is the bacterium. So it's a necessary but insufficient, I would say, cause of your state of illness. So acting on that will most probably help. But of course, we know now that it's not the only factor. So people, when you think about virus, then we've got COVID, and then you've got people getting very sick and people not getting sick at all.
Yeah.
So
it's this separation, isn't it, between disease and illness that I think is so important. That we have a disease state, but then we also have an illness state, and they're not necessarily mutually inclusive or exclusive. They have their own relationship.
Yes, there's some thinkers that they separate the word disease and illness. Like disease is the physical part, while illness is the way we, as a whole, are impacted by the physicality. So disease and illness. I mean, it's a way of looking at that. But the point is that this biomedical model is a model that reduces health and illness to the biology and the physicality. And it is grounded on this idea that ultimately what is real is what we can find in the physical world. So, and in order to understand the whole, we need to first understand its parts.
And that's what you talk about in the book, the mereological fallacy. Or is that different?
Mereology is a way to look. So what I just talked about, that in order to understand the whole, you have to first understand the parts, is a type of reductionism. So there are many ways. I mean, I am myself not a philosopher, but what I learned from philosophers is that there are a lot of versions of reductionism, and probably what I say now is even not that precise either. But there are we can at least look at ontological reductionism and epistemological. Ontological is about what there is, and that would be like saying that the whole is made of its parts. The whole is a sum of its parts. And nothing more than that. So it means that once you understood all the parts, then you also understand the whole. While if you think about epistemology, it's about how to know things, and in that case, reductionism would be that looking at the parts is the best way we have to acquire reality, to understand reality. So it's a little bit different. In one case, you think that it's about what reality is, in the other case is what the best method is. Probably talking about medicine, we're mostly talking. We talk mostly about epistemological. So that looking at the parts is the best method to understand reality, probably. But like mereology, sorry, you asked about mereology. That's a view on complexity. Which is, of course, connected to this last view that I talked about. And it's in the book, in the chapter, we talk about this because what we say is that, we say that we talk about complexity a lot, but we don't talk about what complexity, what do we mean by it?
Right, exactly.
And in causality, we have a lot of these. We say like causality a lot, but we don't know what we mean by it. And then we talk over each other. For example, people who say that randomized controlled trials are the best way to see causality. Well, they are right because they think that causality is a difference maker.
Right.
So if you have this view, then of course, but if I say, well, I don't think you see causality from that necessarily, I might, because my idea of causality is, for instance, for example, a pharmacist, I have more a mechanistic view. I mean, we are trained with this mechanistic view of causality. So, but if we both use the word causality, then we talk over each other. Then, and the same with complexity. So mereology is a view of complexity that sees complexity as something is complex because it is made of a lot of parts. And they interact with each other in a very intricate way, in a way. So it has been a way to look at the genome. You know, different genes influence each other's expression, etc. And in this way, the key understanding is that then in this view, all these parts, they of course are context dependent, they make up a context, etc. They will just interact with each other in certain specific ways. Everyone acknowledges context dependence. I mean, I don't think you find any biologist to say that context is not important. I mean, but the point is that these parts do not change. Like if you take them apart, then you will still have the same identity of each part. Then in the whole. For instance, if you isolate a gene from the genome and you, for example, put it in a viral vector and you express it inside the bacterium, for instance, you would produce a protein, which looks like the protein that would be produced in the human body. You know, but it would be maybe, of course, to do different things in the bacterium. But it is the same thing. So we use the Lego bricks as an image in the book.
It's very helpful. I always come back to that thinking, you know, we can't just pull out a Lego brick and do something with it over here and then put it back in and expect it to be the, you know, it's not the same. Well,
it's you know, the Lego, the brick itself remains the same. The thing is that it just a Lego brick. You know, everyone played Lego, so it's that's why it's if we can relate to it. You know, if you have a certain Lego brick, it just can bind or compose, bit together with some specific Lego bricks and not others, and that's the context dependency in a way. And you've got the small bricks, and you can make very big things, you know, huge castles or cities of Lego bricks, which will just be together because they, you know, they just bind to a specific one, etc. But the point is that if you disassemble everything, each Lego brick will not change. It didn't change because it was in that castle. It will still remain the same. And it can this time be assembled to something and become you know, something else. And this is the idea of mereology. So parts are not influenced; they don't change their identity. The whole does not change the parts. The parts change the whole. But the whole do not have the possibility to change their parts. And this is the, you know, it is still a way we think about, in a way. I mean, I think things are evolving more and more, but it has been a dominant view of biology. You know, proteins interact with receptors, because when I went to pharmacy school, we learned the keyhole.
You know. That's what I was thinking about as well, this lock and key theory.
Yes. Lock and key theory, you know, you've got the molecule, you've got the receptor, which is exactly this, no? But of course, every protein will just fit with one type of receptor, you know, because of their three-dimensional shape. And this is exactly what we think about. We think about the Lego bricks. But then each protein and receptor, which is also a protein, have this identity that determines the context dependency. And now it's changing. I mean, I think that it isn't like black or white, like it's not just we're just the other way, but now what we're saying is that there are many domains in proteins that are complex, called complex domains, and that actually are able to induce the shape of a receptor. So actually, protein and receptor, they induce each other's, they're able to induce each other's shape, for instance, to interact. So it's not really like that.
Even at that level, it's relational, you know.
Yes, even at that level. So the point is that the other view of complexity, which we call in the book genuine complexity, is that is this view that parts make wholes. Yes, I mean, we cannot deny that we are made by parts.
No.
We cannot deny that we can take a heart out of an organism. Right. So part of makes by wholes, but in the whole, parts lose their identity. So it's not the same when you isolate, for instance, a gene, the gene will actually not be the same than when it is within the cell and within the organism. So it's not possible to divide the whole in parts and still maintain the same identity of each part. So it's not only that the parts make up wholes, but whole make also parts. And then for that, we use the example of the beaver. I mean, it's a very ecological view.
Yeah, but I like this.
Yeah, so we say beaver, but I mean, we could say human beings as well. You know, we are the best at changing our environment. We change our environment, right? And if we think at us as the parts, then the environment, of course, changes us. Yeah. We don't remain unchanged by these environmental changes that we produce. Although we're able to protect ourselves from it, we're not like living in the ecosystem like a beaver. Still, and we can see it. You know, we can see from what happens around us, pandemics, etc. And we develop to adapt to the environment that we change. So it's not that you could isolate human beings from their environment and then say that they remain unchanged. I mean, this we all understand. And then if we think the same at every level of complexity, this should be the same.
Yeah. I'm thinking a bit here. So I've got so many examples, but like, for example, we do this with nociception. So we pull out a nociceptor, we do things to it, and then we make this assumption that that is somehow relevant to what's happening inside the body. And of course, it holds relevance theoretically and in an abstract way, but a nociceptor, a nerve, is being acted upon in many, many different ways once it goes into the body. You know, and it's like we can't necessarily directly translate what we see in the nociception evidence to what's happening in the pain experience, and that's where that fallacy is somehow becoming really deeply ingrained within our ontology, right? It's just become what is, you know, and that's the interesting thing about what we're doing when we start thinking more, say, more phenomenologically or more whole person or more dispositionally. We're thinking about the human in the environment and how that's having this dynamic relationship with not only how the parts work, but how we understand ourselves and what is the level at which, you know, what is me and what is the environment and where is that boundary. And I think it's super, super interesting.
That's very nice. I think that, sorry, I interrupt you now here, because I just wanted to say that this causal project has a lot of success among physiotherapists and people who deal with pain.
Yeah.
And not the same with other, you know, it didn't touch a nerve in every type of health profession.
Mm.
But people who deal with pain or other complex phenomena
Mhm.
like this, they had to face the fact that it's not always, as you say, that change at the physical level corresponds to a
Mhm.
complex change. For instance, you see often back pain or lower back pain. You have to confront with the fact that although you have the lower back pain, you cannot find a physical image, physical dysfunction in the spine,
Right.
or somewhere else. So the biomedical, to go back to the biomedical model, it fails to explain these cases in which you do have a complex level, a complex phenomenon, and you don't find
Mhm.
a change in the part. At the same time, you have sometimes changes at the molecular level
Yeah.
without changes at the higher level.
Yeah.
And this is very funny. It's not funny. Actually, it's not funny at all, but I think it's very interesting.
Yeah.
I don't know if you followed later the development in the Alzheimer's disease research.
Oh
There
no,
was
I
this
didn't.
dominant theory that the whole cognitive decline was due to the accumulation of a certain protein in the neurons, and that would cause neurons to die.
Right. Is this like Lewy bodies, Alzheimer's? Where is it called Lewy bodies?
It's all types. So this is
Yeah.
the really main theory, apart,
Yeah.
really the main theory,
Yeah.
including early onset, late onset, genetic or not, although
Yeah.
these are two different things.
Yeah.
But still, the theory was that for all types of Alzheimer,
It's this
there
protein.
would be this accumulation of this protein. But then, of course, you would see that there are these old elderly, and then when you look at their brains, you see accumulation of protein, and they're doing just fine.
Yeah.
And and that is not a very, the theory fails to explain that type of evidence. And now you get accumulating evidence that shows that maybe we got it all wrong. That was not the point. And you've got opening to different types. So people start saying that maybe Alzheimer is a kind of a syndrome. So you don't have one physical explanation that can account for the cognitive decline. So it's might be immunological. Someone says it's an immunological reaction to the environment.
Mm-hmm.
Someone says, it makes a difference if you're multilingual, for instance.
Mm-hmm.
So you learning Dutch, Laura, could be good not only for profession, but for other things.
Oh, well, my dad had Alzheimer's, and we've got a strong Alzheimer's connection in my family, so that's always
So
nice to hear.
Yes. Multilingual is a protective factor, and this is not understood, So there is, and affection, the way you are, your family life, and there is physical activity.
Yeah.
So these are these are high level phenomena, and it is a kind of a mystery. How will this affect neuronal decline? It's very interesting because now we are developing the theory and going more to a top-down level. So it's a real nice field to follow how the theory develops there.
Yeah, it is, and I think it's very interesting to be alive in a period where, we've had such certainty, and now we're moving into a period of uncertainty. It's a bit like, the scientific revolution all over again. We're seeing this real rejection of the uncertain theories, like, oh no, I don't want to look at that. That's too uncertain for me. And then this real sort of like almost zealot uptaking of it, and then everybody's on their mission to change the agenda, and it's a very interesting period just to observe what's happening in healthcare right now, because it does feel like we're in some kind of renaissance period, or some kind of there's a huge shift happening, or that's about to happen. Especially when I think about predictive processing, you know, a lot of what you're saying, I'm thinking about the theory of the free energy minimization principle, and how we might be, you know, when we think about taking a part out, we're changing its integrity, we're changing its ability to predict the environment and its ability to understand the environment. And then we put, you know, that's a very different type of biology to something that's alive within the lived body, within a living world, you know.
Yes.
Yeah. Yeah.
It's really, you're right. I mean, I don't know. I think that more or less every, probably it's such a, things are happening all the time. Probably people living 20, 30 years ago were also thinking, oh, now we are in a such exciting period. You know, I don't know.
Maybe that's our ego, right? We just think this is the
no,
most.
I think things are evolving all the time, but I think you're right. For instance, another recent thing is that you know, it's called the monoamine theory of depression, or like you know, this idea that there are some transmitters, neurological transmitters, that are the cause of some psychiatric condition, for instance, depression. For instance, you don't have enough serotonin. This was the typical. And then we've got evidence, more and more evidence, showing that that doesn't fit. And we don't know why. You know, you've got these famous drugs that target serotonin that sometimes work, sometimes don't. They help a lot of people, and now we are at this stage that we actually don't know why. It doesn't seem like serotonin. I mean, it doesn't fit because you've got serotonin accumulation much before any, you know, anything happens in the, you know, so not everyone improves, but of the people who improve, you know, they've got serotonin inhibitor much earlier, so it doesn't really fit. And instead of feeling better, they get they feel worse in the beginning. So it's you don't explain these complex conditions. It doesn't work with explaining at the molecular level only. Still, it works for some people to get the medicine. You know, so it is so fascinating.
It is. I remember working when I was back in St. Thomas's. So we were one of the biggest interventional units for pain. So we did lots of neurostimulation, neuromodulation, implants. And I remember we were so fascinated with the people, like, it doesn't work, it doesn't work. And I was like, well, what about the ones that it does work for? Like, why on earth is this working? You know, why is it that, you know, when we think about complexity in the cases where it doesn't work, there's also unexplained complexity in the cases where it has worked. And we're like, why has all of a sudden this complex experience of, you know, neuropathic or CRPS type pain, why has that improved so drastically from this intervention targeting this very, very highly specific, small mechanism of action within the spine? Like, it blows my mind when I think, well, you know, it's a mystery as to why this has worked in the first place. You know, thank goodness it has, and let's be grateful for it, and, you know, all of that stuff. But we don't always question it so much. We just go, oh well, it must have. And we do that thing where we sort of like do this kind of like reverse analysis, and we're like, well, we did this there, therefore that must have been the cause.
Yeah, it's interesting that you say that, because that you say it's a kind of a mystery, because Rani, my colleague in Cosel, surely says that these things are mystery because we are very poorly equipped to look at the whole in a scientific world where the best way to look at causality is isolation. So our scientific tools are very good for looking at things in isolation, because we need to look at the difference making. We need to isolate causal factors to see whether they are the ones who make a difference. Which is not to say that this is you know, useless. It's useful for some things, but we're very poorly equipped to how do you even do it? How do you look at interaction? So if we think that it's interactions that shape the world, and it's not difficult to say, I think that most people would agree with that. Like it is interactions to shape the world, and not molecules. It doesn't start from molecules, but from interactions. So interactions shape molecules, and we have evidence of that. We see cognitive development is different in children when they are interacting or not. So but then that means that you need to be able to study interactions.
Yeah.
And this is all the scientific method is like, we're very good at looking at things in isolations. So we need new thinking, new ways and new tools to instead study interaction.
Yeah.
Yeah.
Oh, and do you have any like so if you were to design a research study, like how would you go about that then? How would you move forward in that?
So what we say, I mean, and it is not simple, because when we present these ideas, then we get other researchers say, yeah, you're onto something, but you know, it's still far away from, you know, we know, but
yeah.
So, but at least the beginning is that we would begin, instead of starting the scientific inquiry from the part, we would always start from the whole. So first study the interaction, try to find the context and the whole. First the phenomenon in its context, and then go down to the, because we still, you know, we're still stuck with this, that we anyway have to test hypothesis. I cannot think about ways to go if we also don't test hypothesis in isolation. But the problem comes when you start from the isolation, and then you try to make sense of it. And of course, people could say, yeah, but we look at the phenomenon in context. Yeah, but maybe not enough. So for instance, when there's a new field now, raising field of, because I'm in pharmacy, patients' perspectives on drugs.
Yeah.
Yeah, I mean, it's a research field that it's raising now, and it should be probably introduced in the pharmacy study before we start studying chemistry, maybe. But it's a whole different, it's reversing the whole thing. It's so difficult to do, because what we start and we start with the first chemistry, then organic chemistry, then cell biology.
So you're building up.
We build up. After cell biology, we start with pharmacology. How do molecules interact? How do cells? So we build up, and of course, I grew up in this system. I mean, it's not easy, but how do we get used to start from the phenomenon context? How do we get used? I mean, a person being prescribed a medicine is a phenomenon in context, and it's not only the chemistry of the drug that works there. That's not, it's only a part of a small part of the whole phenomenon.
That's only the bit we can control. Everything else is like, that's the only bit we know is definitely happening.
It's a bit we know academically.
Yeah.
It's a thing we can isolate and
yeah.
But we start having a lot of, you know, there starts being a raising field, because of course it doesn't help to prescribe a medicine if the patient, you know, it depends on the perspective of the patient, and as we say, the whole picture.
Absolutely. And I think that's what I'm so like grateful for as a clinician and as somebody that works in education and that's like starting to move into a research field, is that, you know, the Cause Health project helped me to make that jump from biomedicalism and reductionism, and, you know, starting from the from the part and building out, and flipping that upside down and coming from the phenomena and building in almost, and being able to move in both directions, you know, both ecologically in this sort of external world, but also ecologically within this internal milieu as well, and how that might be
Yeah.
happening. And I think that's it's really, well, for me anyway. I'm fangirling a bit now, but I'm so grateful for this movement, because I think ultimately what it's going to do is is change how we do particularly pain care, because pain has this sort of like existence, it doesn't have an existence reality difference, you know, like what a person, when a person has it, they have it, or it doesn't necessarily show up in this sort of really measurable way, like you said. And so we need this movement to shift us so that we can improve pain care for like millions of people, you know. And so I'm really
Mm.
happy, and that's not only just in pain care, but in the wider health um, professions as well. So a
Very nice.
huge thank you, and thank you so much for joining us this morning and for spending the time sort of going through some of your ideas, and explaining this to us a little bit more, and helping us grow and get more and more connected to this topic, and figure out how it applies. And I think I just want to say, like, you know, philosophy sometimes and gets this bad rep of being non-applicable, and like when it's too practical, it's not really proper philosophy. But the way that, because you've made it so grounded within the profession and within clinical practice, because you're clinicians as well, and because you're researchers and doing all this, it really makes philosophy very accessible and very applicable, and I think that's really exciting.
Thank you. I'm happy you say that, and it's all. I don't take the
No,
credit for that, because it's all our philosophers in the group.
yeah,
I think they were really great
yeah,
with this.
yeah.
But thank you very much for the opportunity, Lawrence, for the conversation, and I hope we can keep the conversation going.
Yeah, well, we this is our it's a recurring theme for us every year, to keep coming back to philosophy of science, causation, and clinical practice, and what this actually means on the ground. So yeah, definitely we will be reaching out again over the next few months and in the next year. So thank you very much.
Very nice. Thank you. Bye.
Okay, bye bye.